Hi guys, I'm back with my lectures. This is Mr. Joseph, your chemistry teacher. So today's lecture will be looking at solutions and concentration. Solutions and concentration. Now what's a solution? A solution is a uniform or homogeneous mixture of a solute and what? And a solvent. A uniform or homogeneous mixture of a solute and what? And a solvent. That means solute plus solvent is equal to what? Solution. The solute is usually in solid form, not in all cases, and the solvent is usually what? Liquid. The major solvent, the most solvent we use is what? Water. Water is a major solvent, it's a universal solvent, and it's used to dissolve many substances. So in chemistry, the solvent that is commonly used is what? Water. So salt plus water will give you salt solution. Sugar plus water will give you what? Sugar what? Sugar solution. So it's a homogeneous mixture, uniform mixture of what? Of a solute and what? And a solvent. Salt solution, solute plus solvent will give you solution. So sugar plus water, which is this solute, this is the solvent, which is water, then the solution is what? Sugar solution. Even in acid-base titration, the acid used in acid-base titration are what? Acid solution and salt and base solution. Like when we take sodium hydroxide and you dissolve it in what? In water, you get what? Sodium hydroxide what? Solution. That's what we call aqueous sodium or sodium hydroxide. But the solution used in acid-base titration is known as standard solution. There's a solution we call standard solution. Now, because we're looking at solution and concentration. So when we talk about standard solution, what is a standard solution? A standard solution is a solution with a known concentration. A standard solution is a solution whose concentration is known. And the solution we use in acid-base titration is called what? Standard solution. It's a solution with what? With a known concentration. So in our normal practical, we'll be carrying out acid-base titration. We'll be meant to what? To what? Prepare a standard solution, or in some cases, it's your teacher that will prepare the standard what? Solution. So in today's lecture, we'll be looking at how you can prepare what? A standard what? A standard solution. A solution with what? A known concentration. A solution whose concentration is known is what we call what? A standard what? A standard solution. So once we prepare a standard solution, we know the concentration. So please, let's see how we can prepare what? A standard what? A standard solution. Now to prepare a standard solution, it's as simple as ABC. So we say a standard solution is a solution whose concentration is accurately known, is known accurately. Now, for example, if you have to prepare a standard solution, we prepare standard solution using what we call what? A standard flask. So we call it volumetric flask, graduated flask. It's in different grades. We have 250 cm cube standard flask. We have 500 cm cube standard flask. We have 1000 cm cube standard flask, which is the standard, which is equivalent to 1 dm cube. We have 2000 cm cube standard flask. We even have 5000 what? Cm cube or standard what? Standard flask. We'll always bring it down, or we'll take it up to what? 1000 cm cube, which is 1 dm cube, which is known as what? The standard measurement. Like if it is in 250 cm cube, we can take it up to what? 1000 cm cube, which is 1 dm cube. If it is in 2000 or 5000, we can take it down to what? 1000 cm cube, which is what? Which is the standard. For example, this is an example. To prepare a standard solution, we take 4.240 grams of sodium carbonate, place in a clean beaker, and dissolve in what? In distilled water. So you put it in a beaker, you put the sodium carbonate in a beaker, then you add the water to form the solution, then you dissolve it in what? In distilled water. Then you now take the solution, you transfer it quantitatively to what? 250 cm cube flask, which is the graduated flask, and then you make it up to the mark, which is the standard. You make it up to the mark with distilled water. So once you do that, you prepare what? A standard solution ready for titration. So if you want to titrate, what you do, you just prepare what? 25 cm cube of that 250 cm cube, and then transfer it into what? Beaker. You add your indicator, then you start adding the acid, you start carrying out your normal titration. For example, if we are to determine the concentration of this solution of sodium carbonate, that means 4.240 grams. gram is dissolved in what? 250 cm cube of what? Distilled water. So we have to look for what? The standard solution. We have to look for what? The concentration. So that means if we dissolve 4.240 gram in 250 cm cube, so to make it standard, then 1000 cm cube, how many will dissolve in 1000 cm cube? So you now cross multiply. It will now be what? 4.240 gram times 1000 divided by what? 250. So you cancel 25 and 25 here will be 4. So it will now be 4 times this, which will now be 8.480 what? Gram per what? dn what? dnq. So this is the concentration of the standard solution. That means 8.480 gram of what? Sodium carbonate is dissolved in what? In 1000 cm cube of distilled water. But in 250 cm cube, it will be what? 4.240 gram in 250 what? cm cube. So 4.240 gram of sodium carbonate in 250 cm cube is equivalent to what? 8.480 gram dissolved in what? 1000 what? 1000 cm cube of what? Of distilled what? Of distilled water. So a solution whose concentration is known as what? A standard solution. So preparing a standard solution is as simple as what? ABC. So when we hear standard solution, we use the standard flask or the volumetric flask, just as I've explained. So it's as simple as ABC, a solution whose concentration is known, which is a solution with what? With a known what? With a known concentration. So a standard solution is a solution with a known concentration. So when we talk about concentration, the concentration of a solution is the amount of solute dissolved in a solvent to make 1 dn cube. Just what I explained in my previous slide, that we dissolve 4.240 gram of sodium carbonate in 250 cm cube, which is equivalent to what? 8.480 gram in what? In 1000 cm cube. So the concentration of a solution, it is the amount of solute dissolved in what? In a solvent to make 1 dn cube of what? Of the solution. So the solvent is usually what? Water. Water is a universal solvent, so because it can dissolve many substances. So we'll talk about concentration. We have what we call mass concentration, which is concentration in gram per dn cube. We also have, for example, that the standard solution I prepared is concentration in gram per dn cube by dissolving what? 8.480 gram in what? In 1000 what? In 1000 cm cube. So it is mass concentration. For example, if I take 5 grams of sodium hydroxide, I dissolve it in 1000 cm cube of distilled water, so the concentration will be what? 5 grams per what? 5 grams per dm cube. Then we have what we call molar concentration, which is concentration what? In mole per dm cube. For example, if I take 0.2 moles of hydrochloric acid and dissolve it in 1000 cm cube of distilled water, so the concentration will be equal to 0.2 what? Mole per what? Per dm cube. Usually standard. Remember, there are 1000 cm cube in a cubic decimeter. That is 1 dn cube is equal to what? Is equal to 1000 what? 1000 cm cube. So concentration can be in what? In gram per dn cube, or it can be in mole per dn cube. If it's in gram per dn cube, that's what we call the mass concentration. But if it is in mole per dn cube, we call it what? Molar what? Molar concentration. So it's as simple as what? As ABC. You shouldn't allow all these terminologies to confuse you. They are very, very what? Simple. So we have what we call molar concentration and mass concentration. Let's look at further, problems on concentration and solution. Now, how do we handle, concentration? Just as I said, let's look at further problems on concentration. Now, how do we calculate concentration? How do we calculate amount? How do we calculate volume? How do we calculate mass? How do we calculate molar mass of your solute? Molar mass of solutions? It's as simple as what? ABC. So we just consider concentration in mole per dn cube. When concentration in mole per dn cube, we consider concentration in gram per what? Per dn cube. Now, in calculating concentration, in calculating amount, in calculating volume, in calculating mass, and in calculating molar mass, they are simple as ABC. We just need to just link them up with what? With formulas. For example, if you look at what we have here, concentration in mole per dn cube is equal to concentration in gram per dn cube divided by molar mass. That means molar concentration is equal to mass concentration divided by what? Molar mass. So that means mass concentration, molar concentration is equal to mass concentration divided by what? The molar mass. Then if we want to calculate number of moles will be equal to concentration in mole per dm cube times volume over 1000. That means number of moles, which is N, is equal to C. C is concentration in mole per dm cube times what? Times V, which is the volume in dm cube over what? Over 1000. Over 1000. The volume can be in dm cube, but the volume can be in what? In cm cube. If the volume is in cm cube, divide by what? 1000 in cm cube. Volume is cm cube. But if the volume is in dm cube, we just say N is equal to what? C times what? Times V. So with this, then to calculate the number of moles again, remember number of moles is equal to what? Mass over what? Mass over molar mass. So these are the formulas you need to handle what? Any problem on what? Concentration, on amount, on volume, on mass, and molar mass. Number of moles is equal to what? Mass over what? Over the molar mass, or the mass over the relative what? Relative atomic what? Atomic mass. So with this, I think we'll move over to what? To solving problems on when it comes to what? Concentration in normal acid-base titration. So this is a typical example. Example 1. Calculate the concentration in mole per dm cube of sodium hydroxide if 250 cm cube of its solution contain 2.0 gram of what? Sodium hydroxide. We are given the molar mass of sodium hydroxide as what? 40.10. So this is as simple as what? A, B, C. We have to calculate the concentration in mole per dm cube. Remember, we have concentration. Number of moles is equal to what? Concentration times what? Volume over what? 1000. Please, let's take note of this formula. Then the next one, remember, number of moles is equal to what? Mass over what? Over molar mass. So the first thing we're going to do is that let's look at the values we are given. They give us the mass of sodium hydroxide, which is equal to what? 2. They give us the volume of sodium hydroxide, which is equal to what? 250. And we'll have the molar mass of sodium hydroxide, which is equal to what? 40. Then we have to calculate the concentration. So the first thing we are going to do is what? We are going to calculate the number of moles of what? Sodium hydroxide, since we are given the mass and the molar mass. So number of moles is equal to what? Mass. The mass is 2.0 gram over what? The molar mass, which is what? 40. So I'm to use my calculator. So the number of moles now will be equal to what? 0.05 moles of sodium hydroxide. Of sodium hydroxide. So it's as simple as ABC. So since we've gotten the number of moles, the next thing to do now, we'll now apply this formula. Number of moles, which is 0.05, is equal to the concentration, which is C, times the volume. The volume is 250 divided by what? 1000. So what you do, you just need to cross multiply. C times 250 is 250C is equal to 0.05 multiplied by what? 1000. So to get your concentration, it now be equal to 0.05 times 1000. Sorry, 1000 divided by what? 250, which is the volume, which is divided by 250 once you cross multiply. So let me use my calculator. 0.05 times 1000 divided by 250. So the concentration will be equal to what? 0.2 what? Mole per what? Mole per dm cube. Mole per what? Dm cube. So answer is equal to what? 0.2 mole per watt dmq. So you can see it's as simple as ABC. All you just need to do is to apply the formula and and you follow the steps as usual. So it's very, very simple. You can use a shorter method. Let me use another method to solve this. If you are comfortable with this method, okay. But if you are not comfortable, you can use the other method. At the end of the day, you still get the same one, the same answers. Okay, you might decide to use this method. You just go straight. Since you know the number of mole is mass over molar mass, and number of mole is concentrated and volume over 1000, you can just say mass over molar mass, which is equal to number of mole, is equal to concentration times volume over what? 1000. So what you do, you just put in the values. Mass is what? 2 over the molar mass is 40 is equal to the concentration times 250, which is the volume over what? 1000. So what you do, you cross multiply. So what you have here to now be equal to what? 40 times C times 250 is equal to what? 2 times 1000. This is very short. So let me just use my calculator. $10,000, 2,000. So C now will be equal to what? Divide both sides by 10,000. Divide both sides by 10,000. C now will be equal to what? 2,000 divided by 10,000, which is equal to 0.2 what? Mole per watt dm cube. So it's as simple as what? A, B, C. It's as simple as A, B, C. So that is it. So just, make use of the formula effectively and you'll get your answer, irrespective of the method you want to use. You might decide to use the first method or this method. You still get the same answer. So let's check example 2. Well, this is a typical example. This is another example. This is an example 2. Calculate the mass of anhydrous copper 2 sulfate in 55 cm cube of a 0.2 mole per dm cube of what? Copper 2 sulfate. So it's as simple as ABC. All we need to do is just to apply the formula. So let's look at the values we have here. You have the volume of copper 2 sulfate, which is 55. Volume of copper 2 sulfate is equal to 55 cm cube. You have the concentration of copper 2 sulfate. Concentration is 0.20 mole per dm cube. So you have to look for the mass, you have to calculate the mass. So given the volume and the concentration, so we need to look for the number of moles so we can get the mass. So we now say number of moles is what? Concentration times volume over what? 1000, because the volume is in cm cube. So what is the concentration? 0.20 times what? 55 over what? Over 1000. So let's move on. So 0.20 times 55 divided by 1000 is equal to 0.011 moles. So this is the number of moles. So now we have to calculate the mass. Remember, number of mole is equal to what? Mass over what? Molar mass. So to get the mass, you cross multiply. Mass now will be equal to what? Number of mole times what? Times the molar mass. So the mass now will be equal to, what's the number of mole? The number of mole is 0.011 times the molar mass. So copper is 63.5. So we have to calculate the molar mass, 63.5 plus 32.1, which is for sulfur, plus 64. So you have what? 159.6. So 0.011 times 159.6. So you now have what? 1 point what? 7 what? 75556 gram. So approximately 1 point what? 756 gram of what? Of copper 2 sulfate, CuSO4. So as you can see, it's as simple as what? It's as simple as ABC. So this is just, the beginning. You have more questions to solve on, concentrations and what? Solution. So before I end today's class, I'll be giving you a task, to solve against next class. Please, as you can see, it's very, very simple. All you just need to do is to apply the formula. Please make sure you take note of the formula and then apply the formula correctly. So, and I also encourage you to solve as many questions as possible, and also attempt the tasks I'll be giving to you. And I believe you'll be able to You'll be able to handle them properly. So they are simple as what? A, B, C. So attempt as many questions as possible, and in our next lecture we'll meet and we'll take the corrections and we'll solve more questions on solution and concentration. So I'll be giving you 2 questions to solve. So this is the task. Calculate the concentration in mole per dm of the following solution. You are given the relative atomic masses. The first one is a solution of sodium hydroxide containing 2.0 grams of sodium hydroxide in 50 cm³ of solution. Then the second one is a solution of ethanoic acid containing 12.0 grams of ethanoic acid in 250 cm³ of solution. So please attempt these questions and also attempt other questions in preparation for our next class. So thank you very much. Once more, I'm Mr. Joseph, your chemistry teacher. Please feel free to reach out to me in case you encounter any difficulty in trying to solve this task or any other tasks. And I strongly believe that by the time we meet in our next class, most of you must have solved these questions, and I strongly believe you get the right answers. It's as simple as ABC. So feel free to reach out to me in case you encounter any difficulty. Subscribe to my YouTube channel. Go to the comment section and give your feedback. Once more, I'm Mr. Joseph, your chemistry teacher. I'm always there for you. So feel free to reach out to me any day, anytime. Thank you very much.